continue with chapter 6, ionic and molecular compounds, and specifically in this video we will be focusing on attractive forces that are present in between ionic and molecular compounds. When we talk about attractive forces that are present in compound, we are talking about the force of attraction that is present between two molecules of the same compound. So these forces are basically present between two molecules. What is the difference that we have seen up until now? We saw two types of bonds, ionic bond and covalent bond. That basically means when we are talking about two atoms, for instance, if I say water molecule, right? So water molecule, or let's say HCl. If we pick an example of a molecule of HCl, the forces that is keeping H and Cl together is a covalent bond, the bond that is present between H and Cl. So this bond is present between two atoms. This bond is present within the molecule. The force of attraction present within the molecule is called the intermolecular force, which is present within the molecule. So H and Cl make up a molecule. So this force of attraction between them is within the molecule. Therefore, it is called intramolecular force. And this is basically either ionic bond or covalent bond. In the example that we are looking at, HCl, it's an ionic bond, but basically it can be any kind of these bonds. Now, when we talk about HCl, there is also a force or multiple different types of force that is present within two HCl molecules. This force of attraction which is present between two molecules is called as intermolecular force. And this is the force of attraction that we are going to focus on in this particular video. So this is the force of attraction between two molecules, not atoms. Here we are talking about two different molecules. This is called intermolecular force, or the force of attraction between two molecules. What are these forces? These forces basically will keep the molecules together next to each other. Okay, they will basically, when we talk about solid, liquid and gases, when we talked about this in states of matter, what we saw was, in case of solids, the molecules are very closely placed next to each other. They are very compactly arranged around each other, right? So this is a solid. What happens when in case of a liquid? In case of liquid, the molecules are a little far apart from each other. Not a lot, but they are farther apart from each other in comparison to solids. What happens in gases? This is solid, liquid and gas. In case of a gas, these molecules are very far apart from each other. What keeps them together though? What keeps them together is this force between the molecules. Higher is the force of attraction between the molecules, the more closer would be the molecules to each other. So basically, if you look at solid, liquid and gases, you can tell which of these have more force of attraction between them. Solids would have the greatest force of attraction, then liquids, and then gases would have the least amount of force of attraction between two molecules, because they are so far apart from each other that their force of attraction is weaker, right? Whereas in case of liquids, they are closer to each other, so there's a force of attraction between molecule. It's present between all the molecules, okay, irrespective of which molecule it is. Solids, the force of attraction is really strong, right? So here we're talking about the strength of attractive force between different molecules, which is also called as intermolecular force, or it can also be abbreviated as IMF. So IMF stands for intermolecular force. When we talk about strength of IMF, solids have the highest amount of strength, strongest forces, then liquids and then gases have the weakest intermolecular force. Okay. So intermolecular force is basically anything that keeps the molecules together. So now when we talk about two different types of compounds we have seen, one is ionic compound, which is composed of ions. Ions basically exhibit attractive force, that is electrostatic in nature, which basically is a force of attraction between positively charged and negatively charged atoms or molecules. This is called ionic bond, right? In case of covalent molecules, there can be, along with covalent bond that they formed, covalent bond is again within the molecule, right? But between the molecule, there are three other forces of attraction that are present. Although these force of attraction is much weaker in comparison to ionic bond and covalent bonds, they are very important in predicting the properties of molecule. These three forces of attraction are called either a dispersion force, it's also called as London force, dispersion or London. The second is dipole-dipole force of attraction, and the third one is hydrogen bonding. Okay, so these are three different type of attractive forces that are usually present in covalent molecules. And these are, even though they are very weak, they can still be very significant in predicting what is the property of a molecule. So let's see what each force of attraction is defined as. So the first force of attraction we saw was dispersion force, or this is also called as London force. What is this force? This force is the weakest force of attraction out of all. It is weakest of all of the attractive forces, okay? But this is present between all the molecules. All the molecules in this universe basically have dispersion forces. It can be a non-polar or a polar molecule, it does not matter. Irrespective of it being polar or non-polar, each molecule is attracted to other molecule by dispersion force. Why is that? So let's say if this is a molecule, one molecule, it consists of an atom where we have nucleus in the middle and then there are electrons around it. This is the same atom, there is nucleus in the middle and electrons around, but what happens at some times whenever these molecules come close to each other, remember these electrons are going to repel each other. So these electrons, when second molecule comes close to this is the nucleus and these are the electrons, these electrons repel each other, they do not like each other, so they move the electrons away from each other. So the electrons here get redistributed in the molecule. So in this molecules you can see what would happen here, the electrons will get redistributed, the nucleus will basically move away. The electrons will move away and the nucleus will come closer to these electrons. So basically what is happening here in this molecule, what happened, the electrons, the nucleus was in the middle, the electrons are distributed. What would happen, the electrons will move closer to the other molecule and the nucleus of the other molecule will basically come closer towards these electrons. So there would be a force of attraction between these electrons and the nucleus, and this nucleus would be moved away. So electrons basically repel each other. So electrons of this molecule and electron of this molecule will move away from each other and they will try to repel each other, okay? And because of this, this particular molecule will have a partial positive charge because now nucleus, instead of being in the center, has moved right to the corner, and electrons, instead of being all over around it, they have moved to one side of the molecule. So this molecule, even though it is a non-polar molecule, it has become slightly polar, which is called induced polar, okay? It's not really a polar molecule, but it has been, polarity has been induced here, that is called induced, okay? So these, because of this induction of new polarity, this has a force of attraction, the two molecules have a force of attraction between them, which is called dispersion force. So dispersion forces are caused by temporary dipoles, meaning temporary polarity, that can be developed when molecules bump into each other. So originally they were non-polar, but when they come close to each other, these electrons redistribute around the space in the molecule, because of which the molecules become induced polar, okay? So they create temporary dipoles, like right here. So when they bump into each other, the nucleus of one and the nucleus of other basically are the farthest apart from each other. The nucleus and the electrons are redistributed. So these electrons will make it partial negative. They'll come close to the nucleus of the other, which is partially positive. Negative and positive attract each other, and this is called the dispersion force. Okay. The next type of force, it is a dipole-dipole force of attraction. Dipole-dipole, essentially, as the name suggests, what is a dipole? Dipole is created when there is polarity, when the molecule is polar or when the bond is polar. Whenever the molecule is polar, there would be a force of attraction between two polar molecules, and that would be called as dipole-dipole force of attraction. What does that mean? For instance, we saw HCl molecule is a polar molecule. Cl is more electronegative, so it is partially negatively charged. Hydrogen is partial positive charge. What would happen? When the next HCl molecule come closer to this HCl molecule, the partial negative chlorine will have a force of attraction for partial positive hydrogen of the other molecule, and the molecules will have a force of attraction because of this, and this is called the dipole-dipole force of attraction. Okay. The next type of force of attraction is called the hydrogen bond. Hydrogen bond is formed between hydrogen atoms that are bonded to fluorine, oxygen, or nitrogen, and a lone pair on fluorine, oxygen, and nitrogen. Okay, so hydrogen bond, whenever hydrogen is bonded to either fluorine, oxygen, or nitrogen, any of these atoms, this hydrogen will basically be able to form a hydrogen bond. Why? Because fluorine, oxygen, and nitrogen are very electronegative. So when hydrogen is bonded to any of these, this will have a partial negative. Hydrogen will always be partial positive. And these atoms are also electron rich. They have lone pairs. So this hydrogen will, which is partial positive, will form a bond or force of attraction with those extra lone pairs. And that is called hydrogen bond. For instance, if I pick a molecule of ammonia, like ammonia shown here, ammonia is basically NH3. So let's say if this is NH3, it has 1 hydrogen, 2 hydrogen, and 3 hydrogen, and this is nitrogen. Okay, let me rewrite this. So this is nitrogen, this is hydrogen, and hydrogen. So what would happen here? This nitrogen will basically consist of a lone pair, and these hydrogen, because nitrogen is so electronegative, it will be negatively charged, and hydrogen will be partial positive charge. Now the same next molecule of ammonia would have the same thing. This would be the nitrogen, which has lone pairs, and then there are these 3 hydrogens, which are all partial positive, and nitrogen is partial negative. So now these dipole, this molecule is polar. So these dipoles that are created in here, the negatively charged will be attracted towards the positively charged hydrogen. And this bond, which is specifically formed between hydrogen and a lone pair on nitrogen, oxygen, or fluorine, is referred to as hydrogen bond. Okay, so remember, only hydrogen which is bonded to fluorine, oxygen, or nitrogen can form hydrogen bond with one of these lone pairs on these atoms, and this is referred to as hydrogen bond. Even though the name says it's a bond, this is not a bond. This is still a force of attraction. It is just called as a bond. Okay, hydrogen bonds are the strongest force between covalent molecules. So when we talk about the force of attraction, the strongest is hydrogen bond, then it is dipole-dipole force, and the weakest is dispersion force. And the strong forces of attraction are, of course, ionic bond and covalent bond. But these are again not force of, these are just not force of attraction. These are present within a molecule, and these 3 forces are present between molecules. So that is the difference between all of these forces of attraction. These are very important. Why? Because they affect the properties of the material. Properties like their melting point, their boiling point, their freezing point. Why is that? Because melting essentially means solids are getting converted into liquids. That is melting. What do solids have? Like we just saw, solids have a very strong force of attraction. So all the molecules in solid are very closely and compactly attached to, arranged to each other, which means it has strong IMF. Whereas liquid means these IMFs have to break apart, because liquids have more space between them, the molecules, which means the molecules have to move away from each other. So if there is a strong force of attraction between them, let's say there is a strong force of attraction between them, this is not a bond, this is just a force of attraction. This force of attraction has to be broken apart so that the molecules can separate from each other. There could be more gap between them, right? And that is when they will be turned into liquid. So they have weak IMF. So what is melting point? Melting point is the temperature when solids turn into liquids. So if a solid has a very strong IMF force, in order to break that IMF, in order to turn it into liquid, the melting point is going to be really high. Why? Because we have to break, these force of attraction is really strong. So to break this force of attraction, the amount of heat that would be needed would be a lot, which means the melting point would be high. So stronger IMF means higher would be the melting point. Weaker IMF means lower melting point. So this is something that you should remember. Okay, our melting points of compounds are lower due to weak forces such as dispersion force. They are higher due to strong attractive forces such as hydrogen bond. They are highest in ionic compounds due to strong attractive force between ions in the compound. So melting point is highest for ionic compound, then it is for the compounds which have hydrogen bond. Why? Because hydrogen bond is strongest out of all of those. Then it is weak for the dipole-dipole, and the weakest is for dispersion force, because it is higher the IMF, stronger the IMF, higher would be the melting point. So here you can see some example of melting points of some substances. So first important thing is, when you look at a substance, you should be able to tell what type of force of attraction would it have. For instance, if I say fluorine, fluorine is F2, which would consist of this bond. So this means this molecule is non-polar. If it is a non-polar molecule, the only force of attraction it will have is dispersion, because dispersion force is present within all molecules, but dispersion force is the weakest of them all, which means the IMF is weak, which means melting point will also be low. So therefore you can see melting point of fluorine is negative 220 degrees Celsius. But when we talk about a molecule like HCl, what happens in HCl? HCl is, remember now, HCl has hydrogen is negative, hydrogen is positively charged, chlorine is partially negatively charged. So this, negatively charged. So this molecule is polar. Polar molecule consists of two forces. Polar molecule consists of dispersion. Dispersion is present everywhere. But along with dispersion, they also have dipole force. Right? Which means this would be also weak, but it would be stronger IMF in comparison to fluorine. So the melting point for this would be higher. So in comparison to fluorine, you can see HCl has higher melting point. It is negative 115. If we talk about something like ammonia, what happens in ammonia? Ammonia is again a polar molecule, if you remember. So if this is polar, it would consist of dipole-dipole force. It is polar, so it will also consist of dispersion force irrespective of what molecule it is. And this is hydrogen here is bonded to nitrogen. Remember, whenever hydrogen is bonded to nitrogen, fluorine or oxygen, it also makes hydrogen bond. And if it makes hydrogen bond, that means this would be hydrogen bond is the strongest of them. This is strongest IMF. If IMF is strong, which means melting point will be high. So you can see for ammonia, melting point is -78. For water, melting point is 0 degrees, which is even higher. So water has even higher or stronger hydrogen bonds and force of attraction in comparison to ammonia. How about NaCl? NaCl is an ionic compound. NaCl is basically composed of metal and non-metal, so it is ionic, meaning Na plus Cl minus. This is a very strong force of attraction between electrostatic force of attraction between positively charged and negatively charged. So this is the strongest of all, strongest IMF of all, meaning the melting point will be highest of all. So out of fluorine, HCl, ammonia, water, NaCl will have a stronger melting point. Similarly, MgF2, when we talk about MgF2, it would consist of Mg2 plus, F minus, F minus. So there are more force of attraction here, which means this would be even stronger and higher melting point. So basically the rule is high, strong IMF, high melting point. Weak IMF, low melting point. Okay. Alright, this is just a summary of what we saw up until now. So ionic bond is a force of attraction between atoms and ions. Covalent bond is also a force of attraction between atoms, which is covalent means sharing of electrons in non-metals. When we talk about between molecules, that's when we say hydrogen bond, dipole-dipole, or dispersion. Out of all of these, dispersion is present in all the molecules, irrespective of being polar, non-polar. Dipole is only present in polar. This is present in polar or non-polar. This is present in only hydrogen, which is bonded to fluorine, oxygen, or nitrogen. Covalent bond is present between non-metals and non-metals, so molecular compounds. Ionic bond is present between metal and non-metal. When we talk about strength, dispersion is the weakest, then we have dipole-dipole, then we have hydrogen, then covalent, and then ionic. This is the strength of these bonding and the attractive forces. So the question could look something like this. Identify the type of attractive force that are present in liquids of the following compounds. Is it ionic bond? Is it dipole bond? Is it hydrogen bond or dispersion bond? How would you do this? Again, to do this, you have to figure out if the molecule is polar or non-polar. And depending on that, you would decide. So if, let's say, if we are talking about water, H2O. H2O will consist of, basically it's a polar molecule. And it will also have hydrogen bonded to oxygen. So it will consist of hydrogen bond. If hydrogen bond is present, that means this will consist of hydrogen bonds. How about NCl3? NCl3 is also a polar molecule. So this will consist of dipole. So when you're looking at molecules like this, you're basically looking for the force which is more prominent. So dipole-dipole force. When we are looking at Br and Br, this is a non-polar molecule. So non-polar molecule only consists of dispersion force. Okay. KCl is an ionic compound, right? K and Cl is ionic, so this will consist of ionic bond. Ammonia is NH3. NH3, again, this here we have hydrogen bonded to N, which means this is also polar, and this will consist of hydrogen bond. So that is all that you need to know about the attractive force of attractive forces that are present between molecules.